Hello and welcome to the Daily Space for today, October 22nd, 2019. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Today is one of those crisp, cool fall days where getting out of bed is a little more difficult than it should be, and the desire to just stay bundled up in a blanket all day is great. But we are here because, well, the weather that we have here is a bit different than the weather that we have on other worlds, and we have weather-related news to bring you today. Our first news story comes to us, well, by Earth-based scientists who have been studying the planet Saturn from both here on the surface of our world and also using the Hubble Space Telescope. Our seasons, as we here in the north, go from summer to winter, and as the southern hemisphere goes from winter to summer, our seasons are driven by the tilt of our planet and how that tilt, well, gradually changes from being pointed toward and away from the sun as we orbit around it and maintain our orientation relative to the stars. Worlds like Jupiter that are pretty much straight up and down really don't have the seasonal variations that we have. Now, there are other worlds that are also tilted and have seasons because of this, and one of those worlds is Saturn. Now, we haven't been able to get that great of a view of Saturn's clouds in up-close detail since the loss of the Cassini mission, the planned loss of the Cassini mission back in 2017. But that hasn't stopped scientists from continuing to try and understand what's going on this world. And in 2018, a research team used a series of images to detect and study storms that are like no other storms that we've previously seen. Now, in general, when we think of Saturn, we think of this nice beige blob on the sky. And this particularly beige world does occasionally spawn storms, such as this great storm that was noticed back in 2017. These great storms can form white bands that wrap all the way around the world as, water vapor from lower levels is spun up and brought all the way up to the surface of Saturn. Now, in addition to these great storms, we've also seen small white dots, small white storms coating Saturn. But these particular storms that were noticed in this new article published in the journal Nature, these are neither the great storms, which are seen to occur roughly every 60 Earth years or 2 Saturnian years, nor were they these small white storms that we're used to seeing. This was some intermediate kind of storm like we've never seen before. And there are no real clear-cut understandings of where this kind of weather pattern came from. There is one idea that maybe that great storm that appeared a year earlier drained so much energy from the atmosphere of Saturn that another great storm just wasn't possible. But great storms generally tend to occur every 60 years, and it's not understood how a storm at one latitude could, grab energy from another latitude. So that doesn't really seem to make a lot of sense, but it makes as much sense as anything else, and we don't really have anything else. So it's possible that these storms, maybe this is just a kind of weather that we've never seen before, a rare weather event that cropped up on Saturn and just happened to get caught by these astronomers. So future observations will hopefully help us understand. And it's just kind of cool to know that even as beige and boring a world as Saturn, that admittedly has amazing rings, but the world itself is pretty beige and boring. It's kind of amazing to see that it's capable of spinning up so much atmospheric excitement. Now, we've actually been studying the surfaces of worlds for not that long. It was only 44 years ago today that we were first able to land a lander on another world. And that world was actually Venus. Yes, you heard me right. The world that is the absolute meanest and nastiest to spacecraft. That was the first world we ever landed on. The Venera 9 probe landed 44 years ago today on the surface of Venus and acquired this image of a very rocky but otherwise smooth surface. As it descended through the atmosphere, it was able to measure the acidic contents of that atmosphere and determine that this is a world of death. The probe didn't last that long, but it gave us one of our only views of this particular surface. It was accompanied by an orbiter that continued to work until Christmas of 1975. And while we do currently have a Japanese probe orbiting Venus, we haven't had this kind of up close and personal attention given to Venus in a whole lot of decades. So here's to hoping that while Venus was the first world that we visited, and while it hasn't been one of the most recent worlds we've visited, it will soon become one of the newest worlds to be revisited. So here's to hoping. Okay, from Venus, we now jump to look at our own planet, Earth. And this is an interesting story that I spotted today on Science Alert. Our world is covered in craters that often form oddly shaped lakes, indentations, geological features, and are sometimes really kind of hard to spot. And there are probably still craters out on our planet that haven't been completely identified just because, well, we haven't looked at them with quite the right perspective. This particular ring of vegetation and water is in Sweden, and planetary scientists have looked at it and determined, yes, this is a crater based on the shock features found in the landscape. Well, now we have mining companies going out and looking for things to mine in the crater. And as they've been grabbing core samples from the shocked layers, as they've been digging down through the crater, they have also been finding fossils. And it appears that the region around this crater, which formed about 300 million years ago, the region around this crater was actually teeming with life in a multitude that wasn't common at this era in the Earth's history. These life forms appear to be the kinds of methanogens, the methane consumers that we know occupied our world early on in its history and helped bring us the climate we have today before our atmosphere was taken over by, well, the oxygen producers instead. Now, it doesn't appear that these microbes were brought here by the asteroid impact, although I'm not entirely sure how you would be able to tell if the life was brought here by the asteroid or not. But according to the paper, it looks like this is not what happened. But it does seem to indicate that the environment of impact strikes was kind of just right for supporting life. And this hints that the era of the Great Heavy Bombardment, well, might have just helped bring life to different worlds by creating the situation appropriate for life. This is a new way of looking at panspermia, where it's not the asteroids actually bringing the life from world to world, but bringing the circumstances necessary to generate life. Now, we have a long ways to go before we prove any of these ideas. Right now, this is just a tantalizing what if. And we're going to be keeping a look at this situation and following this research in the months to come. So go team, yay for the miners who dug their core samples looking for minerals and instead found the fossilized remnants of life. All right, so from weather to life, we now go to the potential for death. And I'm going to actually see if I can zoom in on this image And I'm going to drop myself out of this if I can. So what I want to look at here is a fault line through the state of California. And this particular garlic or Gorlick fault line is one that has been inactive for at least the last 500 years. And as you can see in this image, it's one that butts up against the San Andreas fault as well as the San Jacinto fault. This particular garlic fault, I'm not saying garlic is in the vegetable, it's Garlock fault, is an east-west fault. And while it hasn't been active in a long time, that isn't to say that it is dead. And in fact, it has been seen to be undergoing what is called creep in recent weeks. Back the week of 4th of July, there was a ridge crest set of earthquakes. These were magnitude 6.8 and 7.1 that occurred over the 4th of July holiday. And the release of energy and the motion that was released toward the west side of this particular east-west fault seems to have set the Garlic fault into motion. And since then, it has been able to creep along a couple of centimeters of displacement. Now, this kind of creep in some ways is really good. This particular fault, were it to suddenly give way and move, could release release an earthquake estimated to be a magnitude 8 earthquake. But what they're seeing instead is this fault is just happily going along, moseying along, creeping instead of, well, giving way in a sudden burst of energy release and motion. Now, the problem is that it's currently unknown how its motion is either relieving the energy from other fault lines or injecting energy into other fault lines by essentially jamming them up. Now, scientists are saying that one should not be more or less afraid of this triggering what's referred to as the big one with capital B and capital O for proper noun, the big one that is coming to California, that magnitude 7 to 9 earthquake that is expected to strike along the San Andreas Fault. And the reason they say this isn't any more or less likely to trigger that is because that one is due to come any day, and all of the seismologists that study this are kind of expecting it to come sometime in their lifetime. So when you expect an earthquake to come any moment, movement along any one fault is probably not going to make that any more or less likely, since it's already expected to come at any moment. But they are leveraging this movement as a reason to alert people that that big one could be coming at any moment. And this means that those of you who live in California really should have, both in your car and your home, emergency kits with all the, recommended warm clothes, shelter, food, water, flashlight, medicine, all that sort of stuff. There are lots of emergency preparedness guides out there. Find one and follow it. And know that our Earth is very much alive, very much on the go. And it's not just on the go around our solar system. The plates have places to be and things to see, and they are in motion across the surface of our world. So we don't know how long this particular fault is going to continue to creep along. We don't know if it's going to stop. We don't know if it's going to release a magnitude 8 earthquake. All things are possible. And all things are currently being watched by scientists using high-resolution space-based imagery and LiDAR to look for motion, by scientists using seismographs and everything else. This is a very well-monitored part of the planet. And there is a new app being released. You should look for it again if you live out in this area, that is set up to take advantage of this seismograph network to, well, send you, if it can, an early warning that an earthquake is coming. Earthquakes travel slower through the surface of our planet than electronic signals. This means that if a seismograph detects the San Andreas Fault or any of the other fault lines in this area letting loose and, well, shifting the planet around a little bit, it can send a warning that this, well, earthquake wave, the S or the P wave, is headed your way. Seek cover. If you're doing a surgery, pull your hands out of the body. If you're on a train, slow it down. And this kind of warning system is hoped to, well, when the big one comes that they keep referring to, it's hoping to help save lives. So these are the things we know. It's kind of cool. I don't live near this quake, though, so I can say that. Take care, everyone, and be well. And pay attention to our planet. It is just as scientifically interesting as all the other ones spread out across our solar system. And that closes out all the news we have for today. My name is Dr. Pamela Gay, and this show is produced by Susie Murph. Tomorrow, my co-host Annie Wilson will be bringing you our weekly rocket update. This show is a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are supported by you. Yes, you out there. Your bits, your donations, your patronage at patreon.com/CosmoQuestX. That's what keeps us going. That's what keeps the lights on here at our show. So please consider making a donation that will be tax deductible where the law allows. Thank you. Okay, I am now going to take your questions. And please, if you haven't typed them in already, remember to put that purple circle with a star. Thank you for the bits. Thank you, Trucker Cab, for the sub, actually. So thank you, Econ Greg. And there were bits early on in the episode that I also should thank people for. So many noises, so many noises. So I'm going to scroll all the way up to the top, and I'm so sorry for my dueling audio that I had earlier. I forgot to clear the one channel before launching the other. Musical inception. It was not intended. It was not intended. I've also seen questions about whether the fish that was in the opening was real. Yes, I have a tank that is growing algae that I need to clean, containing 2 fish currently, Bert and Ernie. I'm considering getting Bert and Ernie some additional friends. And it lives down here basically because our house is a fish problem. Let's see what else is in here. Thank you, Kevlar, for the bits early on in the episode. Thank you so much. Looking for other questions. Mythtown is like, R.I.P. my SoCal friends, lol. That is, yeah, it's kind of how I feel often. I will admit, I was actually in California visiting a friend of the show, David Joseph Wesley, and his fabulous wife, Miriam, when those 2 earthquakes hit. And the irony of the larger of the 2 earthquakes was we were at Universal Studios when it struck. So we were on the Transformers ride, which just shakes the bejesus out of you anyways. And the ride suddenly paused for a moment, but the earthquake had already transpired. So we missed the little of those 2 big ones. Yeah. Anyways. Yes, our intro. In case of emergency, pull your hands out of the body and step away if you're a surgeon experiencing an earthquake. Thank you, Econ Greg, again. Thank you. And thank you, Trekker Kev, for the 9-month streak. I think that makes you a Twitch baby. Okay, so Henny asks, since Saturn is a gas giant, can't internal things lead to weather like an upwelling from the core? So as far as we know, Um, that kind of thing, an upwelling from the core, for instance, doesn't happen. These are gravitationally held together, big old balls of gas. And in general, things that go down stay down, very much stay down, because, well, gravity just sinks them like an anchor in the ocean. And without some sort of a force to drive things back up, you're not going to get an upwelling. So the kinds of upwelling we see are actually these storms that I talked about earlier. Let me pull that image back up. So these storms, this is the kind of upwelling we see with Saturn. Um, so yeah, it's not that deep down. Um, Veronica is like earthquakes, not just a California problem, ring of fire. She included notes. That's why I attempted to vaguely sing that. It's true. Our world is very much alive in very many places. Thank you, Planetary Pan, for the 7-month subscription. Um, the Ring of Fire is basically a ring of colliding plates around the Pacific that goes across the Aleutian Islands, along Alaska, down through Japan, across Indonesia, back around up through Chile. And it is marked by a combination of volcanoes and earthquakes and active plate tectonics. But there's other places that are still very much active. So Italy is Greece. These are places with active volcanism. Places, Greece less so of the volcanism. It still has some of it. So, like the Oracle of Delphi was actually due to gases rising up through the world. And coming out and being in a cave and making young women high and thus causing the oracle. We see Nepal on the move on a regular basis. So there's lots of active plates all across our planet. Econ Greg comments, grew up in North Cal and never experienced one quake. Should be thankful, but not gonna lie that disappointed. I get that. I get that. There were actually 2 4.5 magnitudes in North Cal last week, I believe. So Henny asks, is the weather caused by rings? No. It's been thought that the shadows from the rings may moderate weather, but it's not a major source of the weather. Like everything else, it's the interplay between sunlight and the atmosphere. And while the rings generate a shadow that moderates what's going on, they don't drive it. It takes the sun to drive it, an energy input, if you will. The Indian subcontinent produces all sorts of tumblers in Kashmir, Pakistan, Afghanistan, Nepal. Yes, there was actually a very deadly quake back in, I believe it was the late 80s in Afghanistan. Our world's alive. It's the only one that we know of that is this tectonically alive planet-wise. I mean, we have Io, but it's not plate tectonics. It's just squished tidally by Jupiter and interactions with other moons. So hey, let's enjoy the ride while we can. Once the plates stop moving, that probably means our world is tectonically dead and bye-bye magnetic field, and we need that to protect us from high energy particles from the sun. So be grateful for our hot internal convection of our planet. So Hanny is asking, can Everest get taller? If not, what would happen if the plates keep colliding? So there's currently a great debate about what's going on with Mount Everest. It's thought that in the big earthquake they had in Nepal, I'm going to say 5 or 6 years ago, that the mountain actually got a few meters shorter. It's still the tallest, but Nepal is currently working to figure out how to get the most accurate possible measurements of its height. One of the things that makes Mount Everest so high is the Himalayas are still in the process of forming. And so, yes, Mount Everest could get taller, but it could also collapse down as it settles when it gets shaken by earthquakes. Mount Everest is about the maximum height that you can grow something on the surface of our world before gravity is like, no, I'm going to flatten that. It's kind of cool. Still kind of cool. But that's all I've got for today. So I am going to go record the podcast edition of this show, find myself some lunch, and then work on so many different things. Thank you all for being here. As always, we're supported by you. And part of that is we're going to be doing a massive hangout-a-thon the weekend before Christmas, just like we did last year. This year, our goal is to fund all of our media programs, servers, and software through next year. We're going to try and fund all of our citizen science projects through grants, which I'm currently busily writing. So just like NPR does their yearly funding drives, we're going to do our own. And we're in the process of finding guests to come in. And if you have any suggestions, please let us know over in the Discord. We are still in the earliest of planning stages, so now is your chance to, let us know what you want to see and how you think we can make the Hangout-a-thon the best possible ever. Okay, so once again, this has been the Daily Space. My name is Dr. Pamela Gay, and tomorrow I won't be the one here. It will be Annie Wilson with your weekly rocket update. This show is produced by Susie Murph, and we are a production of the Planetary Science Institute, a 501c3 dedicated to exploring our solar system and beyond. We are so grateful that we are here because of you. Thank you for all you do to support us through your bits, your donations, and your patronage at patreon.com/CosmoQuestX. I am going to go find someone to raid in just a moment. And if you have any suggestions, I am open. But for now, have a fabulous morning, evening, or afternoon. Bye-bye.